Welcome to day 5 of calculus. I'm particularly excited because today we get to expand our factoring abilities. If I just gave you a polynomial like this one right here without any other information and said factor that thing right here, it might not go too well because it's pretty big and we don't have a way of kind of cracking it open. Well, I'm going to give you a little bit of information, and that piece of information is that x squared plus 2 is a factor of this. What that means is that x squared plus 2 times something, let's call this polynomial p of x, is equal to p of x. If I wanted to find this question mark, I would have to divide p of x by x squared plus 2. So we're going to do something that you maybe will remember from elementary school or middle school. We're going to do long division. But instead of just long division, we're going to add a word to the front, polynomial. Polynomial, I can almost get it right. There we go. Polynomial long division. Super exciting. So what we're going to do is first set it up, and that is done by writing x squared plus 2, which as our divisor being divided into our dividend. And there's one little thing here. You need to make sure the dividend is written in order, and so is the divisor, descending power. So first we have x to the 4th. Then it's 2x cubed. You have to be very careful. There's this one. And then 3x squared, then 4x, then 2. We've done it in descending order. So we've set this up. It should look kind of familiar. You might have done things like 12 into 14,208. But now we're doing it with polynomials. The key to polynomial long division is one phrase. It is leading over leading. So what I mean by that is you look for the leading term of the dividend, and you divide it by the leading term of the divisor. So that's going to be x to the 4th over x squared is x squared. Woohoo! So that's our first thing we put up here in the quotient, right up here. And that's going to be x squared. Oop, gotta change colors. If I can actually let it, there we go. X squared. And now you multiply. You take what you just placed up there, and you notice I placed the x squared over the term with x squared just for organizational purposes. It's very helpful. We're going to multiply that x squared by both of these things, that whole thing. X squared times x squared is x to the 4th, and then you have plus 2x squared. And you'll notice that I wrote them underneath the terms that share the same power. You put parentheses around it and a subtraction. Let's now do the subtraction. X to the 4th minus x to the 4th is 0. There's no x to the 3rd term here, so you're still going to be left with 2x cubed. It's dropped down. Well, 3x squared minus 2x squared is x squared. And then this drops down. You have plus 4x plus 2. You're now going to do the exact same thing again, leading over leading. Now our leading term is 2x cubed. Can't really see that in the red. I'll make it blue again. 2x cubed. So it's 2x cubed. This leading stays the same, x squared. Well, that's going to be 2x. You now take that 2x and you put it up here. So it's going to be plus 2x. And now you do the same thing. You multiply. It's a repetitive process here. Take this and you multiply times both. And you end up with 2x cubed plus 4x squared. And you do the subtraction again. You do the same subtraction. You do the same subtraction. You might have just caught that I almost made a mistake there. It's not squared because it's 2x times 2 is 4x. So when I line that up, it should really go over to here. It's really easy to make mistakes. Parentheses around the whole thing, subtract. 2x cubed minus 2x cubed is 0. And then you have x squared. 4x minus 4x is 0. So then it's just plus 2. Same thing one more time. Leading term is now x squared, still x squared there, so it's going to be x squared over x squared is 1. Put the 1 up here, the 1, didn't get the highlighter there, 1 from there to there, and now you multiply by this one. So it's going to be 1 times x squared is x squared, and 1 times 2 is 2. You subtract, and look, it comes out to be 0. So if the remainder, this is what we're left with here, the remainder is 0, it should be 0 because if something is a factor, when you divide it in, it should divide evenly. So what does this tell us? It tells us that this question mark that we were searching for right here, this question mark, is equal to x squared plus 2x plus 1. It tells us that this times x plus 2 is that big polynomial right there. Again, if you know something is a factor, when you divide it into the other thing that you know it's a factor of, the remainder should be 0. Is the remainder always going to be 0 when you do polynomial long division? No, it's not. But if you know something is a factor, the remainder should be 0. Has to be 0. Let's do another one. I've copied down the dividend. It was in the proper order and there were no gaps. That's nice. So again, leading over leading. Our leading for our divisor is always going to be x squared, and in this case is x to the 4th. So we have x to the 4th over x squared is x squared. We place it over there. So this one went to there. Now we multiply. So it's going to be x to the 4th because of that multiplication, and x squared. Really pay attention to the details. Minus in parentheses around the whole thing. It's super important. So when you do this subtraction now, when you do this subtraction, x to the 4th minus x to the 4th is 0. So you have minus x cubed and then minus 6x squared because it's negative 5x squared minus x squared. And then you have minus x because that drops down, and minus 6. The new leading term is going to be negative x cubed. This one stayed the same, so it's x squared is minus x. So let's take this one right here, minus x, and we plug it in right there. Now when we multiply minus x times x squared is negative x cubed. Minus x times 1 is minus x. We do the subtraction, we get 0 minus 6x squared. Negative x squared minus negative x squared is 0 again. So it's going to be minus 6, just dropping that down. There's a 0 there. So when you do the subtraction, you do the new leading term. The new leading term is this negative 6x squared. So let's take that, and it's negative 6x squared. This one is the same. So you have minus 6. So now you take that minus 6 and put it up here. And now you multiply, and you get minus 6x squared because you're multiplying by x squared, and negative 6 times 1. When you subtract, you end up with 0. We knew it should be 0 because we were told that this is a factor. If you came up with something other than 0, if that indeed is a factor, then you've made a mistake. So it should be 0. Remember, leading over leading, and it's the same thing over and over again. So let's do a third practice. We have x minus 5 being divided into x to the 4th minus 3x cubed minus 14x squared. It just keeps on going, doesn't it? It keeps on going. You even make that long enough, man. So I did it out for you. There you go. That's what it would look like if it was polynomial long division. What's really nice is that there's a quicker way to do it when you have factors that are linear, just like this, x minus 5. X minus 5, no, just 1 as a coefficient of x. There's a faster way, and it's called synthetic division. It's super cool. So to set up synthetic division, the first thing you do is you think of what number makes the divisor 0. So what makes x minus 5 equal to 0? Well, that's x equals 5. You plug that here, and then you do a symbol like this, and then you take the coefficients, all the coefficients here. What are the coefficients in order? Well, it's 1, and then negative 3, negative 14, 12, and 40. Okay, so that's the setup. You're going to do something over and over again. You start this by dropping the 1 down right there, and then you multiply it by this number, whatever it is there. In this case, it's 5. 1 times 5 is 5, and you plug it right there. You then add these together to get 2. Next up, you do the same thing. You multiply by 5. 2 times 5 is 10. Add them together to get negative 4. Multiply by 5 again. These are all multiplied by 5. Multiply by 5, you get negative 20. And then you add them and you get negative 8. Multiply by 5. Again, it's the same number. And you get negative 40. Add it together and you get 0. What synthetic division does is it tells you what happens when you plug in a number into a polynomial, meaning when you plug in 5. When you plug in 5 into this polynomial, you get out 0. But here's another cool thing. Take a look at the numbers that lead up to 0. What do you see there? I see 1, 2, negative 4, negative 8. hey, take a look up here. What do you see here? I see 1, 2, -4, -8. So you can call this the constant. Sorry, excuse me. You can call this the constant. This is the x term. This is the x squared term. And this is the x cubed term. So what's 1 times x cubed? X cubed. 2 times x squared? 2x squared. -4x. And this is just constant. 1 is -8. Take a look. This is the same as that. So again, write everything in order. You drop the first term, and then you just multiply repeatedly by the 5, which is what makes this 0. We'll practice this a bunch, but it's going to save you a lot of time. Remember, synthetic division only works with factors like this. X minus 5, x plus 2, has to be x plus or minus a constant. So let's do another. We can use synthetic division because this is x plus or minus a constant. What makes that 0? -3 makes it 0. You then take the coefficients. You have a coefficient of 1, -1, -9, -3, and -36, and place them in order right there. Drop the 1. Now you're going to just repeatedly multiply and add, multiply and add. So 3 times -3 is -9. Add them together to get -10. Multiply by -3 again, and you end up with 30. Add these together and you get 21. Multiply together and you end up with, as you may have caught, I didn't drop the right number down there. What number do I need to drop down to start? You drop down 1, the same number you start with. Multiply by -3, add. Multiply by -3, add. Multiply by -3, add. Multiply by -3, add. Oh, look, it came out to be 0. So remember, the mistake I made was I didn't drop down the right number. Drop down that first number. It ends with 0, so we know divide it evenly, which is great. So this is the constant. This is the x term, the x squared, and the x cubed. So we know that what we'd get if we divided this by this right here is x cubed plus, minus 4x squared plus 3x minus 12. That's what happens when you divide. That's what happens when you divide our big polynomial there by x plus 3. So what that tells us is one factor of our original polynomial is x plus 3, and the other factor is what we found right there. So we have factored this. Now we might not have fully factored it because we need to factor this cubic. Now the method we have for factoring cubics is factoring by grouping, where you take the first two terms and you think, what can we pull out? Well, that's going to be x squared, so it's x minus 4. And what can we pull out of the second two terms right here? Well, let's pull out a 3. So it's x minus 4. And remember, we still have this x plus 3 on the outside. What's in both of them? Well, we can't really see it, but it's x minus 4. So the x plus 3 is still there. And then you factor out an x minus 4. And what are you left with? X squared plus 3. That's the fully factored form right here. This is a ton. We will practice this extensively. We'll practice it extensively.